All right, everyone. Welcome to session 5. It is Wednesday, October 18th at 6:07 p.m. Central Time. We're going to go ahead and jump right into it. There's only a handful of slides for this evening, and then we're going to go right back to what was the last challenge that we had? I believe it was. We did the prep work for it, but that did finish it. I believe it's the illegal word challenge. And then we're just going to jump right into the illegal word and start picking out new challenges for the evening. All right. So, and I apologize, I'm also going to cover a couple of things that I went over last session and try and explain them a little bit better because I got myself tripped up a little bit when I was using the dot map, and I did figure out what I did wrong with that. All right. So let's see here, and everyone can see my screen okay?
Yes.
Okay, cool, thank you. And right, so this is, we're gonna talk about scope tonight, and scope is, we've already been using it, but we're gonna explicitly talk about it tonight. So in JavaScript, scope refers to where variables and functions are accessible in your code. So at the global scope, any variable declared outside of a function is going to be in the global scope. You can access these variables anywhere in the program. Anything defined inside the function is only accessible to that function. And I'm sorry, and this is local scope. Anything defined inside of the function is only accessible to that function and any functions or blocks of code inside of it. And so let's go ahead and do a quick demonstration of this, right? So if I say, we'll just call this global var equals 10. And then I say, we'll call it function add, let's call it add 5 to it. All right. And I say return global var plus 5. Right. And so let's go console.log, add 5 to it. Right. And there's my function call. And if I run this, I get 15. Now notice I didn't give my function a parameter, right? I didn't have to give it any type of input in here. It sees this global variable, right? And it acts on it. Now, same thing, I could say let, we'll call it local var equal 5, right? And then we can get rid of this hard-coded value here, and we'll call it local var. And if I run this, I still get 15. Oh boy, no, we're getting this in the console. Replit never ceases to amaze me. Now, with local variables, that is the only place I can see this is inside of my function. That's what we talk about local scope. So if I say console.log local var down here, I get local var is not defined because it is local to this function. I can't see it anywhere outside of here. And when, just like with some of the other things that we've talked about, so like when we were talking about equality versus strict equality, and we wanted to default to strict equality, and when we write conditional statements, like or conditional logic, like we want to make sure that like our very narrow scopes in our conditional logic are written first, because if not, they might be swept up in a broader conditional logic, like, and then we never get to our specific case. It's the same thing with local and global variables. We want to, whenever possible, use a local variable. And the reason being is because this function can see it, and so can this function, right? So I could say multiply by 2, and I could return global var times 2. Now, with what we know about this, when I run console.log, add 5 to it, and then we're going to do multiply by 2. Let me comment this out. So this will come here. Visible at the global scope. What two numbers do you think we're going to see over here? Anyone want to take a stab at that? Like, we already know what the first one's going to be. It's going to be 15. What's going to happen when I run multiply by 2?
Should get 20.
Yep. So with that, and I'm sorry, because you are correct, because I actually set this up wrong. If what I'm trying to demonstrate is that they can actually impact each other, but because of the way I wrote this, it did not impact them. But if I do something like this, so I can say, we'll leave that there, and we'll say global var plus equal local var, right? And then return global var, right? And that's what that was supposed to be my big dramatic reveal, but I screwed it up. So you got me. So what can happen inside the local scope of this function is we can mutate this global variable, right? And then we're impacting every other variable downstream from it, right? Because now then I just returned those two numbers added to each other, but I didn't reassign the value to 15 up here. But when I write it this way, now I'm actually saying plus equals. So that is the same as saying global var is equal to global var plus local var, right? And so I've now reassigned the value of it. And same thing, if I come down here and do the same thing, so say global var, I can say times equals here 2, and then just return global var here, I'll still see 15 and 30. Right, but if I just come down here and console.log global var, right, it's 30. I've permanently changed the value of this and impacted other things. Now, same thing here. If I had another function that said, right, and now if I run this, right, so now I've screwed everything up, right? And so this is where we want to avoid global variables whenever possible, because multiple things can mutate them and maybe you don't mean to mutate them, right? And so this helps us protect ourselves and protect our data. So whenever possible, if we want to do things within the local variable scope, we want to be passing them into the functions and not leaving a global variable up there that the rest of the application, or excuse me, the rest of the file can see and then make changes to it. Because again, I'm just coming up with like little basic changes here, but sometimes like manipulating data, when I was showing the JSON, like we start getting into like nested arrays, they're like nested array of objects, things along those lines, or where if we're looking at a file that maybe has 50, 100, 150 lines of code in it, then there's a lot more chances to screw things up. And especially like if we start getting multiple global variables, right? So like, let's say I have a file where now I have like 10 or 15 global variables at the top of it. That's just a lot of basically you're making it much harder on yourself because you're going to have to keep going back up to the top of the file to see what's going on or what things are happening. Like we always want to try and keep as much as possible compartmentalized in the functions that we're writing. All right. So any questions on global scope? Or I'm sorry, on scope in general. Okay. So let's go ahead and roll this forward. Right. So again, just what we talked about. So at the top of the file, if we wrote let name Tom, this would be accessible anywhere in your code. The name variable is accessible within the say hello function because it's within the global scope, right? We'd still get the output and local scope, right? So if we write a function, we've got the curly braces here. We can access age inside the function, but if we tried to access it outside of the function, we would throw the error, right? It would tell us that it's not defined because it can't see it at the global scope. Hoisting. So hoisting is a JavaScript mechanism where variables and function declarations are moved to the top of their scope before each code execution. This, you don't need to worry too much about this, especially if you're writing clean code. All it's saying is that like when you hit run on your code, and remember, if we go back to like the first couple nights, this is doing two things at once, right? So like we're declaring a variable and then we're assigning it a value. It will move like, so when JavaScript hoists, it actually pushes it up to the top, right? So if you declare a variable down here and you start running things, like JavaScript will push the declaration up to the top of the code. But you should get in a habit of like you said, like grouping your variables. Notice how like even within like my global scope or my local scope, like then you'll see this within the challenges, right? Like we declare our variables up at the top of the function and then we go to the code. We don't rely on JavaScript to do that for us. All right, and that is it for all of the slides on session 5. Any questions for me on any of this before we get into challenges? Okay. 1 second here. All right, so I'm in Replit because I've already cloned it. All right, I believe it was the illegal word. Did anyone take a shot at this already? Yes, no, maybe.
No, I haven't.
Okay, cool. So, and sorry, before I hop into this, I did want to cover one other thing with you, and that is because I believe it was in the remove zeros challenge, where I had screwed up with the dot map. Let me go ahead and pull this back up. So this will go, and this is not just for dot map, this is for any callback function, right? And so we look at MDN dot map. Right, so we will see same thing here, like same format as all the other ones, right? So like we get a description, the map method of an array instance creates a new array populated with the results of calling a provided function on every element in the calling array, right? And then we get a little demo of how it works, and then we start to talk about the syntax. And whenever you see this, right? This is a callback function. So a callback function to execute for each element of the array to return values as a single element in the new array. The function is called with the following arguments. All right. And so the format for a callback function is this, right? It is your parameter, just like writing a normal function. You just don't write function and the name of it. You just go straight to the parameter and then you give it a fat arrow. And lots of built-in methods use callback functions, right? So .map does, sort is going to, right? So we come down here, well, they call it a compare function here, but again, it's going to be the same format. And then, and again, I apologize, it won't be the same format because the compare function will always have two elements that you need to compare. A callback function can have one. That's why they basically delineate there. And then also, I believe like filter is, find that, right? So filter, right? So see, we see that same thing as X with the other one, but we've got, again, you've got your parameter and you've got your fat arrow, and then you've got your function. So, right, we've got another callback function. And this is doing .map with the correct callback function. And what I did wrong is when you do a callback function, if you do it, the default is to do it on a single line, right? So it would look like this. So if I run this, right, I get the correct answer. And with a callback function, you can, if you need more space, right? Like if you're going to write a more complex function in here and it needs to be written out over multiple lines, you can give it curly braces, just like you would a normal function. Which is basically what I had typed in. And where I screwed up is once you put in these curly braces, when it's on a single line, there is a implicit return. So notice how like this function doesn't actually say return, right? There's a return for the remove zeros, but there's no return for my .map callback function. And you don't need one when it's written on a single line. But once you go to multiple lines, you do need a return in here. And so you would have to add basically the, so we'll say let answer equal this, and then return answer. And then, oh, that's that, right? So now it's working again. What I had done is because I was trying to make it look pretty, instead of having it on one line and bring it down here because of the join, I made it over multiple lines and remembered that I need to do curly braces, but I did not remember to throw my return in. But so that is how you use a map, and kind of like a brief intro to what a callback function looks like. Let me, we'll just leave that there for right now. And we'll go ahead and go over the illegal word prep work again, and then we'll get everyone split out into groups unless there's questions for me, and then we'll keep moving throughout the evening. All right, so just to refresh ourselves on this one, for a legal word, we write a function that takes in a sentence and an illegal word and returns a Boolean indicating whether or not the sentence contains the illegal word. Capitalization should not matter. Right, so it's telling me I need to make this thing case insensitive. So we're getting two parameters. Both of them are going to be strings. The first one is a sentence that we're going to look into, and the second one is a single word that we're going to be looking for. All right, and we're going to return a Boolean, either true or false, if that word, the illegal word, is located in our sentence string. So for the examples, notice how down here, we've got hello there and fudge. So like we would expect this would return false. In the test, they threw in an exclamation point. So that's reversing it. So if your function works correctly and returns false, so this will actually say true, and these two will resolve to true in the console if your function is written correctly. And notice how, but I didn't say fudge, and then we've got it with a lowercase and then with a capitalized letter. And so this is where it comes into how do we standardize the characters that we're looking for and make sure that we're case insensitive. All right, and which is our first bullet point up here. And so we know we've got a couple of different built-in methods here. It doesn't matter which way you go with them as long as you do the same for both of them. And I usually recommend that you do that right up in the as quickly as possible, so you don't forget to do it later and it causes a issue by missing a step. Right, so we know that this could be solved with just string dot includes, so I could just say sentence dot includes word and that's it. But again, we're going to solve this without using dot includes. And how can I isolate each word into something that I can compare against, right? So we did that in one of the previous challenges. We just did it with digits. And then once I have each word isolated, what do I need to do to compare them against my illegal word? And what do I do if I find the illegal word? Okay, so we've got, it looks like 2 groups of 3 this evening. So I will try and swap them up, and I know people will pop in and out as the evening goes. But for right now, I'm going to pause the recording. All right, everyone, it is 6:51 p.m. Central Time. Welcome back from the illegal word challenge. So we broke out into a couple of groups here and took a stab at it. And now we're going to go over the solution in class. All right, so like always, I'm going to try and solve this step by step and break it apart. So I know that I want to be able to look at my sentence. All right, so let's just go ahead and run this and see what we get. All right, so hello there, but I didn't say fudge, but I didn't say fudge. All right, cool. So that is what I would expect to see. And I do get a true here because basically it's not returning anything, which is undefined, which is in the world of truthy and falsy is falsy. And then because we've got that bang operator there, that turns my falsy into true. But we're going to disregard that for right now. All right, so first things first, I need to figure out how to make my search case insensitive, right? So if I say word, right, sorry, this is, okay, so there are my words attached to the end there, and let's do this to make it easier. All right, so that'll give me a little formatting when we do this. Or it'll say not a number, which is because I did that there. There we go, that's what I was looking for. All right, and sorry, this, I don't know how to disable this, and this is again, a brand new feature. It wasn't doing this any night before now. All right. So let's go ahead because we see our capital letters in here throughout this. Let's just send everything to lowercase. All right. And all right. And so now everything across the board is lowercase. So we can do this right away up at the very beginning. And we'll say sentence is equal to sentence to lowercase, and we'll say word is equal to this. All right, so now I need to figure out how can I, and again, so I could solve this by saying sentence dot includes word, right? And I'll run this. All right, so I get my trues here. I'm not sure where this, oh, because this is console.logging false. And I'm not returning it, but if I return it, right, there are my three truths. Like that is all you need to do to solve this. But because we've put the restriction in here of not using the dot includes, we're basically going to write our own dot includes function. And so for that, what I would take a look at doing is I know that I need to go in here and I need to take my illegal word and I need to compare it against hello and then there and but and I didn't, so on and so forth. How do we take a string and split it up so that we can compare each word in the string? We've used this in another challenge. Does anyone remember what to do there?
I think Sean used it. Wasn't it?
Yeah, we were using the dot split.
Yep, that's exactly right. So, and remember, you don't have to put anything in there. So, sorry, let me, okay, so I can use that little trash can and clear it out. All right. Right. So if I don't put anything in there, it defaults to throwing the whole thing in there. And if I just put an empty string in there, I think it like does it on every single letter. But if I do it on spaces, now I've got every word as its own individual element and an array. Right. And now how can I iterate through an array?
We used a for loop.
Yep, that sounds perfect. So let's go ahead and we'll take this dot split and we'll throw this here. And now we're just going to console.log sentence this time, right? And we still see that it's splitting everything up. So we can remember, as long as we're doing it in the right order, we can chain our built-in methods together. So now I need a for. So we can say for let I equal 0, I less than sentence dot length. Whoops. Okay, sorry. There's my typo. And then I plus plus. Right. And we talked about it at the beginning of class, local and global scope. So even a for loop is basically a predefined JavaScript method, right? Like it's built into the JavaScript language, but it also has scope, right? So if I try and console.log I down here outside of my for loop, it'll tell me I doesn't exist. But inside the local scope of the for loop, my I exists as a variable that I'm able to access and use. Right. And so now I can say send, we'll take this and we'll move it up into here. And then because we want to access it by the index, and remember, so as we iterate through, we're going to do sentence 0, sentence 1, sentence 2, so on, up through the length of the array, right? So now when I run this, I get each individual word. So now I can do something like this, and I can say, is it equal to word, right? And now instead of seeing the individual words, I'm going to get all the Boolean values, right? So false, false, true, so on and so forth. And because I'm running it multiple times, none of this really matters which one belongs it to, but we know that we're seeing it as this. So what I can say now is if sentence I is strictly equal to word, we can return true, right? And now I could write an else in here and return false, but I can save a little bit of code here and just put a return false down here, right? Because if we make it through, I'm sorry, not here. We make it through the whole loop without hitting something that causes us to return true, we can exit our loop and just return false at the end. All right. And so if we run this again, right, there's my truths. I'm passing all three of my tests. Any questions on how I solve this one?
Okay, so we got all true because the first test code had the exclamation, right? And it does the reciprocal of what a function is doing.
Yes, so the exclamation point, which is the bang operator, reverses the polarity of something, right? So it gives you the opposite. So if I say console.log true, right, I get true, but if I do bang true, I get false. Right, and same thing here, because what it's doing is the first time through, fudge is not in the sentence, so it's returning false. So this resolves to bang false, which then when we console.log it is true. Right, so same thing if we say one strictly equals one. Right, we get true. If we take this and we can basically reverse our true by just adding a bang operator in front of it. And like I said, it adds confusion. I usually don't like this. Like I would have, if I would have wrote this, I would have just wrote a note saying like the first test should return false and leave the bang out of there. And it's less confusing, but you will run into that in code sometimes. But I usually, when I run across it in like production code, like I'll try and figure out how I can clean it up and remove it because there's usually a better way to write
Okay, thank you.
it. Yep. Any other questions on this? Okay. So I was looking at this. We just finished a legal word, and I think we're going to do the caffeine control. And then we're also going to do, after that, we're going to do fizz buzz. And those will be the challenges that we try and get through today. Fizz buzz is going to be a little bit more complicated, but this is a fun one. And this is also a super popular interview question. All right, so let's go ahead and grab caffeine control. We're going to fork it. Now let's do the prep work and then we'll get back out into the groups. All right. Okay, so every weekday you drink caffeine to get ready for the morning. Monday, you need 800 milligrams to wake up from the weekend. Tuesday, you only need 600 milligrams. Wednesday and Thursday, you only need 400 milligrams. But on Fridays, you drink 900 milligrams because you're going to put yourself in the emergency room. I don't know if anyone's ever tried to take down 900 milligrams of caffeine in a single sitting, but it's generally not a good time unless you've got a pretty good tolerance to it. So because you'll be staying out late and going crazy with your friends. You prefer buying small energy drinks that contain 150 milligrams of caffeine each. Write a method that takes in a day as a string and returns a minimum amount of caffeine drinks you will need to buy. All right, so let's go ahead and take a look at this. We're going to get one param, which is a string representing the day of the week. And a integer, and we'll say number integer that represents the number of cans of energy. Okay, so we'll say C below. All right, so a couple of different things here, right? So we know we will be getting a string input of M, T, W, R, or F for the days of the week. And then Okay, so we could possibly solve this using some data structures. We could also solve this using some conditional logic and some math. There's a couple of different ways to do it. Both ways would technically be right. So, and if you can think of it one way and not the other way, don't worry about it. You're good. Are there any questions for me before I split everyone out back into groups? And I'm gonna try and shake the groups up again.
No.
Okay, so let me go ahead and pause here. All right, everyone, it is 7:36 p.m. Central Time. We're back from the caffeine control flow and types challenge. So we're going to go over a solution here in class. Okay, so like we always do, we want to do this a step at a time. So we're going to console.log day just to see that we're getting our variables passed through correctly, right? So there's my Monday, there's my Thursday. I think, yeah, ours is Thursday. Okay, so I need to figure out how I want to store some values. Sean, I know your group got a solution. How did you store the values of the different amounts of caffeine that you needed for your group?
We chose to store it in an object.
Okay, cool. And the other group was doing that as well, and that's usually how I would recommend to do this. Right, so we could say let caffeine, I'll just say caf needed equals curly braces. So remember, so we're declaring our variable, then we're going to assign it a value, and right now it's an empty object, but we're going to fill that in. So we're going to do Monday, and I know that's 800. Tuesday was 600, and what was it? Wednesday and Thursday were both 400. And then Friday is going to be 900. Okay. Let's go ahead and take a look at this now. So if I do console.log caf needed, I get the entire object. And I only want to get individual values out of here. And when I am accessing individual values, I can do that through dot or square bracket notation. Like I said, I usually just do it as square bracket notation. And so I can do day. And now instead of seeing the whole object, what I would expect to see is the first time through is I should see 800. And the second time through, I should see 400. All right, and so let's go there. So there's my 800 and there's my 400. Okay, so we're on the right steps here. And so now I need to basically do some math, right? And I believe it was 150 milligrams per can of caffeine. And so what I'm going to need to do is take this number and divide it by 150. All right, so let's go and throw that in there. All right, now I'm at 5.33 cans and 2.66. And both of these are repeating cans. And we know as part of this is that we can't go under, right? So we prefer buying small energy drinks that contain 150. And you'll need to have at least that much. So again, on 400, I need 3 cans basically for 450. And for 800, I need 6 cans. Because 5 cans is only 750, and I'm not quite hitting that 800. Okay, so let's take a look here and say, how do I round up a float in JS? All right, so math.round. I don't necessarily want it just to be round. I want how do I round up always? Right, so ceiling, it looks like. So let's type in mdn.ceil. All right, the math.ceil static method always rounds up and returns the smallest integer greater than or equal to a given number. So 0.95 would be 1, 4 is 4, 7 repeating all the way out is 8, and then -7 rounding all the way out would round up to 7. So that looks like what I'm looking for. So I can take this whole thing and wrap it in math.ceil. Figure out this input. And there's 6 and 3, which are the numbers that I'm looking for. I'm still getting false because I'm not returning anything yet. It's just a console.log. Let's go ahead and peel this out of the console.log. We'll say return. And I get my true. So this is what I'm looking for. If I were to take something like this and we'll say, whoops, what did I do there? Let's go ahead and do Friday, should also be 6. All right, there's my trues. And same thing here, if I do, I always want to make sure that maybe we'll throw in a wrong number to make sure that I get false. All right, so that's false. We know that we're getting it. Okay, so there's that. And the only other thing that would be different would be Tuesday. And that should basically be returning 4. Right, and so this is how I would solve this one. Now, to make this a little bit more useful, there are things that we could do, like what happens if the right, like not every energy drink or however your drink has the same amount of caffeine in it. So instead of hard coding the value 150, like we could create a second variable in here that would say like caffeine per drink or something like that. And then that way we could divide by different amounts and get different numbers in there. But this is pretty much what the solution for the problem as it is stated. The other way that we could solve this without using an object would be a switch statement. And I always get this, it's either a switch statement or a case statement. I think it's a switch statement. Okay, so it's a switch statement. And has anyone ever seen a switch statement before or know what they are? It's another way to do conditional logic. So for specific cases, and there's some uniqueness around this, but instead of just writing an object, we could always write a case statement, or I'm sorry, a switch statement. I'm just going to grab this and I'm going to pull this over here and I will comment this out. Throw that in and we will say day. And then we can take our case here and we could say Monday, Tuesday, Wednesday, Thursday, and Friday. All right, and here we can say this. So we'll say so let path amount, and we'll say equals 0. And then we can say in here, path amount equals 800. Path amount equals 600. And then and I'll explain what I'm doing here shortly. We'll say cap amount equals 400. Notice how I skipped over Wednesday, and then cap amount equals 900. All right, so if we take a look at this now. When we do this, so this is basically like, we could also solve this with an if else statement or an else if statement. So, right, like we'd say, if day is equal to M, if day is equal to this, if day is equal to that, all the way down the line. And let's go ahead and run this. Oh, let cap amount. Oops, that doesn't belong inside my switch statement. Sorry about that. What need a colon here. And we get false. Okay, so let me pull this out of the if else statement here, and it should say false because I haven't. Here, console.log half amount. And what I would expect to see down here is 800. I wrote this correctly, and I did. All right, and so we do this one. All right, there's our 900. Right, so 800, 900, 900, and so we are getting some issues in here, right? And the reason being is that when we write these can fall through without the break statements. And so I did not put a break right here, and this should clean this up. There we go. There's my 400. So 800, 900, 400, 600. So this looks better to me. And so this is a switch statement. And with it, you can, each switch, so each case can have a return, and that will exit out of this. But if you are not doing a return, this will fall through. And so that's why we have to have the breaks. And if I take these out, right, when I run this, I'll get 900 for everything. Because what happens with the switch statement is the first case that it runs into, it will enter into the switch statement, but then it will keep doing every single one underneath it as well. All right, and so that is what the breaks are used for. It actually punches you out of the case and out of the switch statement altogether, and you move on with the function. This right here is an intentional fall through, right? So because both Wednesday and Thursday are technically 400, I should be able to write a W right here, and I should get 400 for that one as well. Right, and there's my 400 at the bottom. So we hit the case Wednesday, nothing happens, but there's no break in here to tell us to stop falling through the cases. So it falls into the Thursday case, we assign caffeine amount, the value of 400, then we break and we exit. Right, and same thing here now, I can divide this by 150. Wrap the whole thing in math.seal and return this. Oops. Right, and I get some trues, but then at the very end, I do get a false. That is because Wednesday is not equal to 4, it should be equal to 3. Right, and there's all of my trues again. So this is another way of solving it without using the object. Either one is perfectly fine. Any questions about either solution, either this or a switch statement? I know this is probably the first time most people have seen the switch statement. Okay, if there's no questions on this one, let me go ahead and pull up the next challenge. And the next challenge is going to be FizzBuzz. fork that, bring it over. README. Do to 1. All right, so a couple of different things here right from the get-go. With this, remember that keys are always treated as strings by JavaScript. So even in this example, where you see like the number 1 here or whatever, when you do right? See, JavaScript is automatically throwing those quotes around my number 1. That is perfectly fine. You won't be able to get it to print out in the console without the quotes around it. So don't worry that it looks like this. On this side, if you give it a number, it should recognize it as a number, right? And it does. Notice how it's gold. There's no quotes around it. So you'll have numbers here, strings here, but these are all on the left-hand side. All of these keys are strings. They just don't have the quote marks around them in the example, but you will see them when you print it out in the console. All right, so we are going to write a program that prints an object with a number of keys. The key is the number, and the value is either the number, fizz, buzz, or fizz buzz. But for multiples of 3, assign the key's value to equal fizz instead of the number, and for the multiples of a 5, assign the key's value to equal buzz. For numbers which are multiples of both 3 and 5, assign the key value to equal fizz buzz. Otherwise, assign the key's value equal to the number. All right, so we are going to get one param, which is a number representing our total count. All right, and we're going to return one thing, which is an object that contains key value pairs of the number as a key, so the number of the count as a key, and the number as a value, fizz as a value, buzz as a value, or fizz and buzz. And let me sure I'm not doing anything crazy or misleading over here. All right, so you see below. All right, so I've got 4 possible outcomes here. All right, and so my most restrictive, and remember, we've talked about this a couple of times now in class, and I'm going to stomp my foot on the ground, and this is a hint for how you should tackle the problem. When we're writing some conditional logic, our most restrictive conditional logic should come first, and our most restricted conditional logic is for fizz buzz, right? So fizz buzz, if the number is divisible by both 5 and 3, right? And then buzz, if the number is divisible by, I said buzz by 5, is if the number is divisible by 3, and then just the number if it isn't divisible by 5 or 3, right? So 4 bullets above outline my 4 possible outcomes each time I iterate through my count. I know I will need a loop to iterate my count. I will need some sort of conditional logic to choose the appropriate outcome each time I loop through. All right. And so also need to know how to create new key pairs inside of an object. All right. And that is and that's the format that you use for that. There's nothing tricky there, but we haven't talked a whole lot about creating new key value pairs. So this is the format that you'll use for that. Are there any questions for me before I put you into the breakout rooms? All right, so this is available in the intro to coding channel. There's a lot here. So I don't think I'll be able to drop, well, let me just drop the prep into, I'll do this, should fit into the Zoom chat. And it does, so that's in there. Let me shake up the breakout rooms. All right, and any questions for me before I move everyone into the breakout room? All right, everyone, it is 8:30 p.m. Central Time on the dot. Welcome back from the FizzBuzz Challenge. We're gonna go over this in class and we'll discuss the solution, answer any questions, and then we'll be about done for the evening for session, that was session 5. All right, so with FizzBuzz and with part of this, they hype it up. So the FizzBuzz test is an interview question designed to help filter out 99.5%. So whatever random high number of programming job candidates. I don't vouch for that number, but this is a super popular interview question because it's going to be using looping and it's going to be using control flow, right, to get an answer. This version of it also has a data structure in it. So we've got the object in there that we're constructing. So we're up to the point where we need to know like 3 or 4 different basic building blocks here that we're going to be using so that we can solve this problem, right? And again, as always, how I advise to do it is that we figure out how to break this down one part of this at a time, right? And so really we need to figure out how to store the data, how to get our loop to do the right count, and then how to choose if we're going to be doing just the number as a value, fizz, buzz, or fizz buzz as a value, right? And so let's go ahead and get started on that. And I know that I'm going to need an object. So I'm just going to create my object here and say results. And then I know at the end here, I'm going to return my results. Right, and there's my empty object. And as I said, when we're creating a key value pair, sorry, let me go ahead and just wrap this in console.log. So if I return results now, right, I just get the empty thing. And this is down here. We'll comment that out. Right, so there's my empty object. And I gave you the format for how we would do this, right? So I would say results. And we'll just say a key of 1 is equal to 1, right? And if I do this again, there's that. And same thing here. If I do results, 2 is equal to 2. There's both of my key value pairs of my objects. So that's all I need to do to add objects in there. Now, the next thing I need to figure out how to solve for is doing a loop, right? And so I can say for let I equals 0, I less than num, I plus plus. Right, and let's go ahead and console.log I, and let's take a look at what we get. Right, so I'm counting from 0 to 19, right? And really what I should be seeing is 1 to 20. And so I'm starting my count at 0. So this first part of this where I'm assigning the value of I, this is going to be my first count. So I can bump this up 1. Let's go ahead and run this again. Right, and now I'm counting from 1 to 19. And same thing here, I can do less than or equal to num, and that way I'm going to get one more iteration of my loop in there. And I'm at 1 and 20. So now I've solved for my count, right? And so now let's go ahead and start to actually assemble my object here. And so instead of doing this as a console.log, let's use results. And we're going to do I, right? Because now we're counting, right? 1, 2. And so each of my keys will go in there sequentially. And I'm just also going to assign the value to I, right? And so what I should see is like 1, 1, 2, 2, 3, 3, all the way up until we hit 20. So let's go ahead and clean that up a little bit and let's run this, right? So there's my object. And again, like I said, don't worry that we see quotes here and no, not over here. JavaScript always treats a key as a string, even if we try not to make it a string, right? Like I'm actually putting the number 1 here, like that is I is a number 1 through 20, and it's still being converted to a string behind the scenes, which is fine, right? So now we need to start actually making some choices here. So now we've hit the part where we need to do some control flow, right? So now I could say something like this, where I say, if I is triple equal to 3, results I is equal to fizz, all right? And let's go ahead and take this, and we'll say else results I, right? I is equal to I. So let's go ahead and run this again. Well, and I screwed that up. So by saying triple equal to 3, I know I did it right. So it's actually changing the value, but it's not if it's equal to 3. It's if I modulo or remainder 3 is triple equal to 0, right? Because that means if the number is evenly divisible by 3, that the remainder should be 0. Let's see what that looks like. There we go. So 3, 6, 9, 12, 15, 18 are all fizz. All right. And now, instead of just going from an else, we can now start to leverage our else if statements, right? So we could say else if I remainder 5 triple equals 0. We can say results I is equal to buzz. Move this else back up here. All right, so now we've got fizz, we've got buzz, we've got fizz, we've got buzz, we've got fizz. So notice we're already starting to run into a little bit of collision here, because remember, so 15 is evenly divisible by 3, and so we hit fizz. So we hit that first one, and then we go, so it never even looks at if I is evenly divisible by 5 or not, right? And so every time right now, the way it's written, it would be basically, it would always do the first one, which is fizz. So if I did I remainder 5 first, it would, when we have that same collision, it would always say buzz. And so that tells me that to get my fizz buzz to show up, I'm going to need to write that one on top. So I'm going to need to rework this a little bit. So let's go ahead and add an else if here for this one. And then we'll say if I remainder 5 is triple equal to 0, and I remainder 3 is triple equal to 0. We do this, we bump this up here onto this line, we can say results I is equal to fizz buzz. All right, and so let's go ahead and take a look. All right, so fizz buzz, we get to 15, there's our fizz buzz, so that's looking good. Does anyone know a math trick that we could use to clean up this if statement a little bit? So if something is evenly divisible by 5 and it's evenly divisible by 3, what else is it always going to be evenly divisible by? It's going to be evenly divisible by 15, right? So 5 times 3, fizz buzz will always basically be evenly divisible by 15. So instead of having this and in here and doing both of them, we could simplify this just by doing it this way, right? And that's a little bit easier to read. And so let's go ahead and run it again because we made a change. We want to make sure that we're still getting the same thing, right? So there's our fizz buzz, still getting it. And let's go ahead and bump this up to 100 and see what we get. All right, so start at 1, ending at 100. Right, so I'm getting a fizz here, I'm getting a buzz here. So this is all looking great. At 15, I get a fizz buzz. At 25, I should have a buzz. At 30, I should have a fizz buzz, right? Because that's 30 divided by 15 is 2, right? So no remainder. And then all the way up to 45, we get that fizz buzz. At 60 would be my next one. And then 75, yep, looks good there. Right, at 80, we've got a buzz. Fizz, or 81 divided by 3 is 27. Right, so we're looking good. All the way up to 100 is buzz. So I feel pretty good about this solution right here. Now, are there any questions on how I went about solving this? Nobody's got anything? So super clear.
You just make it look so easy and straightforward when you do it.
Well,
Right.
so, which is good. Like I want to be concise, so I don't want to be confusing. And when I am confusing, I always try and go back and clear it up. But I also need help because like if I say something that seems confusing, please let me know. Or if I go over something too quickly, let me know. We can circle back around. I mean, like we've got time. Like these were the 3 challenges slated for today. No, you couldn't. And so that's a Robert, this is a good question. No, you wouldn't use return because as soon as you return, remember that is the last thing that a function does. So if I put a return statement in here, like return results up here, the very first time we hit this, it should stop counting at 15. Right, and if I were to put a return here inside of 3, it should stop counting at 3, right? So whenever a return is encountered inside a function, it is the last thing a function will ever do before exiting. Right, so we need to create the keys. And if we didn't do this inside of an object, we could always just do this as console.logs. But the object adds the extra part of learning how to move key value pairs into the data structure. So it does make it a little bit more challenging.
I think our group just had an issue with kind of knowing what to do with the I. And I think that's always been my struggle. You know, when I'm coding is just trying to keep up with what the I is doing.
Yeah, I think we were on the right track, but I think we just need to replace what we had with the I.
Okay, so I is always going to be a number, and I's first value is determined by the first part of the formula, right? So whatever you put here is where I starts counting. Right, and so the second part all right, so with this right, like we're using I to create a key. So but I is a count, and the reason that we're able to do this, right, so like let's say if we wanted to only create keys that were like, we didn't want to do like 1, 2, 3, like we wanted to count by twos, right? So we could do something like this, right? And now instead of counting every time, we're going to get, notice how we only get odd numbers in here. And so we could also count by tens, right? 111 all the way up to 91. So it's however you want to do it. And but most commonly it's just by ones, because if we're going through an element or elements in an array, like we want to look at every element in the array. In this instance for FizzBuzz, like we want to create a count of every number between where we start and where we stop. And so you just have to remember, even within the building block, right? Like we can break it down into smaller pieces. So this first part of the for loop tells me where I'm going to start counting, and this will be the first value of I. The second part tells me when to stop counting, and this will be the last value of I. And then the third part of this tells me how we are going to increment our count. And with that, like I said, in this instance, we want to do it by ones. So just by reading through this, like you should start to get comfortable reading a for loop and saying, okay, this for loop is going to it's going to start here, stop here, and count by this number. All right. And so, because once you get comfortable reading these, then it gets easier to start writing them. And like, again, you get access to these, like save these, you can copy and paste them into your own notes or whatever. But like, this is pretty much what you need to know about a for loop and how to use it. And most commonly, right, like we will use this count to create something, like, so we're using I to actually create keys with this, or we'll use it to access something that already exists, right? So because like if I had an array, right, we know that arrays use index values. And so, excuse me, with like each index value of the array, we know that if we start it from 0, it's going to start from the 0 value of the index, or I'm sorry, the 0 index of the array, and then it's going to count through each of the elements in the array, and we can access them. And so the other big part of I is learning and is remembering how we access things and create things, right? So we can create a key for a key value parent and object by using the name of the object and then the key, right? So I know I've got that up here already, right? So the name of the object. Right? And same thing down here, I'll make a little note at the bottom, right? If we have right an array, we know that this array has index values. And so if I write another for loop, oops, right? I is always a number. So if I just console.log I and I run this, oops. Sorry, I need semicolons and not commas. Right, so 0, 1, 2, 3, 4. That is me just console.logging I. That is how it is counting. Right, and again, if I wanted to, I could do I plus equals 2. Right, and now I get 0, 2, and 4. I'm counting by that. I could do plus 10. Right, and so now I'm going through the length of it, but then like an additional 10. I could start my count at negative 20. Right, and then so I start my count there. And so all of these things are just determined where I start, where I stop, and what I count by. And so let me undo this here real quick and put it back to this. And because this is probably one of the most common loops, for loops that you'll see is when you're dealing with an array, right? And so we're doing the array.length. If I add an element, like I'll still get all of them. If I subtract an element, I'll still get all of them. And I'm not hard coding a value, it'll always count to whatever the length of the array is. And when I just console.log I, I'm just doing the number, right? But we know that to access an array or an element in an array, I can do array and then bracket notation and a number, right? So if I just do 0, I'm going to get Charles a bunch of times in a row, right? Charles. But every time that it loops through, it's just doing this because I've hard coded the value. But when I put I in here, the first time through, this resolves to right, and then 1, and then 2, and then 3, and then 4, right? And then we stop the loop because I is less than array.length is now false, right? Because now I is 4 and that is not less than, or I'm sorry, it would 0, 1, 2, so it would be 5. So I would be 5 here, the actual count, and which I think it was doing that. Go past where I made a weird one here. Taken too long to go. All right, but so the I is 5, that is basically no longer less than 5, it's equal to 5. This is false, we break out of the loop. And so if I run this again, right, there are all of my elements in my array. And so I is always a number, but we can use it as a in basically an index value, right? So we know that if I want to look at all of the elements in the array, 0, 1, 2, 3, 4, I can run a for loop starting at 0, stopping less than the length, and I'm going to get I is going to be 0, 1, 2, 3, 4, right? And that's how I hit all of the different elements. And again, if there's additional topics, like, I mean, even if we've already covered it, this is new for everyone. And say, hey, Charles, can you do an array again? Can you do a for loop again? Or I'm still fuzzy on index values. Like as we go, like, I mean, it took 5 minutes to read the slides tonight, and the slides are pretty thin for the rest of class. I think that I may have already closed the, no, there it is. Right, so we just did 5 tonight, right? So session 6, we're going to talk about higher order functions. There's only one concept to talk about over a couple of slides. Same thing with session 7, session 8. Greg's going to be here to talk about code platoon. There's really no technical stuff in the slides. And then there are no slides for session 9. So if there are concepts that you want to hear again, I'm more than happy to repeat them for you and go over and give different additional examples, because these are the core, like writing a loop, using conditional logic for control flow, and identifying different data types those are the core concepts that you're going to need to be able to pass the application to get into Code Platoon or really any coding bootcamp. All right, so with that, it is 8:57 p.m. So that is the end of class for the evening. Hopefully everyone that stuck around is getting something out of class. I can change things if you want to do less groups. Again, more examples in between. Happy to tailor it to basically get it so that you guys are getting comfortable with introductory JavaScript. But please, please, please ask questions as you have them. Outside of that, I'm going to stop the recording.